Okay, so what we're going to do now is we're going to be doing this converting between moles and masses. To do this part, we only need one formula, and that formula is mole equals to mass given to you divided with mr. Mr here is called molar mass. Okay, molar mass. Molar mass has a unit which is gram per mole. Now, gram per mole, this can be written like this as well, gram divided with mole. It's the same thing. So that's gram per mole. This has a unit of grams. Okay, so gram divided with gram per mole, you end up getting moles. Now, before we do that, I just want to bring your attention to this one. There's these funny words which are called molar masses and formula masses and so on. So let me just clarify this for you. So let's say, like, for example, if I asked you to, let's say I asked you to work out the molar mass of sodium chloride. Okay, sodium chloride. So I know sodium from the periodic table, it has an atomic mass of 23. Chlorine, we just did just now, is 35.5. Okay, so if I have been asked to find the molar mass, what I'll do is I'll just take 23.0 and I add it up with 35.5. I will get 58.5. Okay. But if I'm writing it as molar mass, I will write it as 58.5 gram per mole, because whenever I refer to molar mass, I need to write the units. But you can also get something that says formula mass. Okay, so if the question says, hey, what is the formula mass of sodium chloride? The formula mass of sodium chloride calculation is done exactly the same way, except for there is no units. You just leave it as it is. That's it. Okay, so when you hear the word formula mass or molecular mass or relative formula mass or relative molecular mass, whenever you hear these words, there are no units, but the number is the same. Okay, the number is the same. So if you see words like molecular mass or formula mass is used for ionic compounds. Okay, or sometimes they use the word relative. Let's say molecular mass, it has no units. So the moment they add the word relative, there is no units. In fact, even if there is no word, the word relative is not there. If they say molecular mass or formula mass, please remember, no units. Okay, only molar masses has units, but the numbers are the same. All right, let's move on. Okay, let's clear the page. Let's move on. Okay, let's come back to this. So what we're going to do is we're going to use this formula when we are doing calculations. It's extremely easy. So like let's do this question here. Okay, let's do this question. So the first question says, hey, what's the formula mass and molar mass of copper hydroxide? Okay, so we're going to come to the periodic table. Let's look at copper. Okay, where's copper? Okay, there's copper. 63.5. Copper hydroxide, it has 5. Copper hydroxide, it has 2 times oxygen is 16 given here, 16.0, plus hydrogen is 1.0. Okay, so hydrogen is 1.0. Let's close that up. Let's add these numbers up. Okay, so 34 plus 63.5, I get 97.5. So it's going to be how many decimal places? Because if you remember here, you see oxygen is given to you in 2 decimal places, right? But we have to follow the smaller decimal place, which is 1. So 97.5. Now 97.5, right? So the question was asking us the formula mass and molar mass. So the molar mass is 97.5 gram per mole. Meanwhile, this is just 97.5. No units. You see, same number, just that what is the word used? Is this a big deal? The answer is no. It's not a big deal. It does not matter. It's not life threatening. Okay, so a certain reaction produces 2.81 grams of copper hydroxide. So determine the number of moles. So quite easy. We're going to use this formula. We have been given 2.81, and then we divide this with 97.5. So usually what I do is, when I do calculations, right, I don't put units during the calculation, but at the end of it, I definitely put units down. because it's really important. So I'm getting an answer that says the answer is 0.02882 moles. Then what I do is I refer to this is 3 significant, this is also 3 significant, and so the answer is going to be 0.0288 moles. Okay, yeah, you can see the answer here. There is it. All right, so that's how we do this. Chromium metal is used as a decorative electroplating or car wheels. All right, find the mass of this many moles of chromium. So we're going to use this formula again, and M over MR. So in this case, so if we refer to this, right, if we refer to this, what we're going to do is, we know the moles, which is 0.560. Mass we don't know. What is the molar mass of chromium? Let's look at the periodic table. Oops, where's the periodic table? Let's look at the periodic table, look for chromium. Chromium is 52. So let's come back here. Let's come back here. So chromium is 52.0. So mass becomes, okay, 0.56 times 52. Oops, 0.56 times 52. You get 29.12 grams. 3 significant numbers, 29.1 gram. That's the answer you can see here. Okay. All right. Last question. It says, the last question says, how many moles of copper sulfate are there in 20 grams of copper sulfate pentahydrate? Copper sulfate pentahydrate. So this copper sulfate pentahydrate, right? So what we need to do is we need to find the molar mass of this entire thing. But before that, let's look at the ratio. Let's look at ratio, okay? So you have copper sulfate pentahydrate and the ratio to copper sulfate, because we want to know how many. So if you look at the formula, you should know that in every one of this, there seems to be one of this. So the ratio is 1 to 1. Okay, the ratio is 1 to 1. So once you know the number of moles of copper sulfate pentahydrate, that is exactly the same number of moles as copper sulfate. So we're going to work out the, we want to work out the molar mass of copper sulfate pentahydrate. So how do we do this? So let's do this. So copper, let's look at the periodic table. Okay, let's look at the periodic table. Okay, so let's do this. Let's clear page. Okay, let's look at copper. Where is copper? Hey, I see it. Okay, 63.5. So copper sulfate pentahydrate. That's what we're doing, right? So copper, let's look for sulfur. Sulfur is 32.1. Oxygen was 4 times 16.00 plus, okay, 5 water. So two hydrogens 1.0, this hydrogen here, plus oxygen again 16.00. Let's do this. Okay, so this will give us the molar mass, right? So 5 times 18 plus 64 plus 32.1 plus 63.5, I'm getting 249.6. That's the molar mass. Okay, that's the molar mass gram per mole. Right, and 1 decimal place, because this is 1 decimal place, 1 decimal place, this is 2 decimal places, this is 1. Because if you remember, when we add numbers up, what are we doing? We are focusing only on decimal places. So 249.6, let's come back to this question again. So 20.0 divided with 249.6, what do we get? Okay, 20.0 divided with 249.6, and we get 0.080128. Okay, so how many significant numbers? 3 significant numbers, right? 3 significant numbers, because this is 3, and so the answer will be 0.0801 mole. That's the answer. Okay, you see at the bottom here. So basically, that's how we work out this type of questions, right? So you guys should be able to do the questions from the worksheet. Okay.